Hello, in this short video I'm going to demonstrate some patterns that I find useful with new Golang generics. They're not really new now, they are available since version 1.18, but they're fairly new features of the Golang. And I actually think that most Golang code that I see now just emphasizes that use generic, emphasizes on the usage of generics in writing generic data structures like linked lists or hash sets or these kind of data structures. But I think they are useful in some things that we actually do more often as Golang developers, and they can reduce code, not just provide type safety, but actually reduce the amount of code that we need to do particular repetitive stuff, reduce the boilerplate we need for our codes. So let's start. So first thing that I wrote, first thing that I want to demonstrate, let me silence my phone. Okay, so the first thing I want to demonstrate is a way of writing HTTP handlers that removes the need to actually decode the request body in every one of your handlers, and it does it in a way that does not add any kind of overhead to the runtime. So you can do this with reflection, but with generics it's available and it's compile time thing. It's not a runtime thing. So let's show you first the actual output. So for example, if you are using the standard HTTP module, standard HTTP package, net HTTP, by default you write some handler like this. So get user, and you pass in a response writer and also an HTTP request, and that's it. And when you want to decode the body, you probably need to pass in the request body and also say decode and create a request, for example, of type user. I have a type user defined somewhere, and I pass in this, and I need to check this error, and if error is not nil, I need to do response.write header 400 and return. So this is the minimum thing that you need to write in every of your handlers. And imagine you just want to print the user name out, so if request.name. But with this pattern, or with this library, let me just fix this, you can easily have something like this, and this works. So how does this work? We have a function called std handler that takes in this signature, the response writer, the request, and some object of some type that we don't know, and it turns it into a HTTP handler that we can pass in to HTTP handle func. So let's see this function body. So it takes in a generic function. So it has a generic type parameter called in, which is the body, and tries to do the body decode of that function. And also you can customize this, so you necessarily don't need to just rely on JSON. Some people might need to do XML decoding, so you can easily do that. So you have std callbacks, you have this, you do this. So you have a function that takes in a HTTP request, and see this body decoder, this callbacks type is also a generic thing. So you don't need to rely on any interface. So when you want to write this function, you know what type you're getting, because I wanted this to be generic and have implementations for all frameworks. But at the same time, I didn't want to use any empty interface or any type. So now you can easily say XML.new decoder request what was that, request.body, and then decode into out, and return this, and return this. So you can easily customize the behavior as well. And at the same time, instead of writing this amount of code every time for every single handler, you just write this. There is also implementation for Echo. We can see the implementation. So for example, it's the same thing. We have a user type. By default, you write something like this in Echo. You bind to a type, to an object, not a type. You bind to a pointer. If you cannot bind, there's an error. You just return bad request. Otherwise, you do the logic. But in this pattern, you just print this out. The logic is handled by this echo handler function, which is similar to the STD version. The only difference they have is the type that they return and some framework specific things, like where to get the some stuff. And actually framework specific parts are also in this callback system. So again, in Echo, you don't necessarily need to rely on the JSON implementation or JSON decoder, and you can use an XML decoder, for example, and this just works. So this was the first thing that I wanted to demonstrate. The second thing that I do a lot in source codes, especially when you're writing web servers, and many web apps have some kind of authentication or authorization. And there are middlewares that put, for example, they get a token, they get the JWT token from the request, they parse it, they check with database, get some necessary stuff, and if everything is okay, they will put some user object or user info inside the context of the request. And when you want to use them, imagine this is the request context. What you need to do, let's actually change this to be echo context so I can demonstrate this better for you. So imagine you have this now, and there's a yes, this is echo v4. So now you do C request context. So by default, what you need to do, let's ignore this for a moment, you need to do something like this. So you do context, and then you do value, and then you need, for example, user info, and then you get some object, and if object, which is of type any, you need to pass it, you need to do a typecast and say, okay, if the object is what I want, imagine a user info, if it's not, return, for example, a bad request. So again, you do c dot no content 400, and this is not return, okay? Otherwise, you do the thing you want to do with the user info. But instead of writing this, and many people might not do this, so this is really important. Web servers handles panic. All web servers handle panic, but panics are expensive in Golang. So for example, if your web server panics, if one of your Go routine panics, that panics will come up to the main thread, and main thread needs to handle that panic. So there are a lot of expensive things happening, and many people might just forget to do this. There are ways probably you can achieve checking of typecasting to check all your type assertions or typecastings to do this okay thing using linters. But it's better if you actually create a convention or a pattern in your code base that does this for you. So instead of writing this, you can do something like this. This is all you need to do. So context.getValue, pass in the context and pass in, for example, the key. Imagine, let's have the same key in here, and that's it. And you pass in a generic type. And this is a really simple function that just says, okay, get this. Is this the type that we expected it to be? If yes, just return it. If no, just return an error. And you can handle your error in here easily. So these are just two patterns that I want to start with. I will add more videos in this topic, but I think generics are a feature that we can really use, and this is and are really useful, and they are not just useful for doing data structures or doing generic data structures. They are useful to reduce the amount of boilerplate you need to write. This is it for this video. If you like my content, subscribe to my channel, like this video, and actually put comments and tell me what usages you have of generics in your code bases. I'm really curious to know what how people use generics. So thank you for watching, and until the next video, goodbye.